Hey everyone, so today we're going to be going through how to implement the method SquareSum in two different ways, iteratively and recursively. So what SquareSum is supposed to do, it's supposed to take in an array of integers and it's supposed to turn the sum of every single value in the array squared. So basically what that means is if we had an array that had the values 1, 2, and 3, what it would do is it would square all the values. It would do 1 squared plus 2 squared plus 3 squared, add it all up, and return the integer sum of that, which is 14. And so that is an intended behavior of this function. Yeah, so and before we start like coding in any way, I think it'd be best if we just think about what actions our method would have to take in both cases. So after we wrote it out, we know that one action it would have to do is one, it would have to square all values in the array. And then the second thing it would do is it would also have to sum all values. So when coding, we should make sure we tackle both of these points to make sure our function behaves the intended way. So let's get into it. The first way we're going to do it is we're going to implement it iteratively. So which that means is we're going to use a loop, such as like a for loop or a while loop, in order to go through all the values. So the first thing we want to do is think about some variables we might need. So one variable that we would need is we would need a integer. Since we're returning integer, we need to have an integer, which we will call sum in this case, to store like all the values that we would like need, or like keep track of a running sum or running total that we have throughout the course of the function. So at the end, we're able to return it. So now we just created a variable we need, and now we have to think about what we want to do. So we mentioned that we have to square all the values, we have to sum the values. And the thing is, since we have to do that to every single value in the array, it'll probably be most efficient if we have some kind of loop to make sure we do it for every single value. So the way I'm going to implement it is using a for loop. Now the for loop has 3 different components. It has an initialization. So we're going to initialize an int called I, and let's have it start at 0. Because we want to sort the first value in the array, and the array start at index 0. And then we have a condition. We need to have to check if we need to continue going through this loop. And our condition is, since we want to go through every single value and values, we want to make sure it's within range of the array. And the indexes in the array go from 0 to length of array minus 1. So we want to make sure that I is always less than values dot length to make sure it gets through every single value, 0 to length minus 1. It never goes out of bounds. And after each run of the for loop, we want to increment I by 1 to get to the next index. So that would be the 3 components of our for loop. So let's go into our for loop now. So now we're starting from I equals 0 or index 0. So at that point, what we want to do is we would want to square the value of index 0. And we could do that by taking values I, and then we do multiplying equals values I. So what this is doing is it's taking values I, and it's multiplying it by values I on the right, and then it's setting that value equal to values I. So basically it's multiplying the value by itself and it's putting it back in itself. So we're altering the value in the array exactly. So after this, we have the value squared. And then we would want to sum it somehow. So we could do that by doing sum plus equals values I. So basically what I'd be doing is it's adding sum to values I. So it's combining those two numbers, and then it's storing that new value into sum. So it's updating the assignment of sum. And yeah, so basically, I think that's all we need to do for each index, and it would index would increment and it would repeat the stat for index 1, index 2, so on to the end. So I think we can end the for loop there. And then when thinking about stuff we have to do next, so we've created our variable sum, we've went through the entire way and squared and summed everything. And I think that's all. After that, I think we should have the actual values. So now, since our method has a return type of int, we'd want to return an integer. So we probably have to put our return type there, or a return statement, and we want to return sum because that's where we've been storing the square sum of all our values. And yeah, that's how you would implement this iteratively. So now let's move on to recursion. So the recursive approach looks pretty similar to the iterative approach, but we have one thing we should notice is that we have an extra parameter in index. So we should utilize an index well in our recursion. And in this case, it's used to represent an index value. And the first call would be to index 0, which is like the first 0th index of an array. So we should keep that in mind in future calls. So usually before I write recursive functions, I usually try to map out two important things: base case and recursive call. So these are two main components of a recursive function. So I'd like to get them out of the way before we actually start coding. So what a base case is, it's the stopping point of recursion. So since recursion behaves by calling a function calling itself multiple times, to avoid like infinite recursion, we need some kind of stopping point or stopping condition to that makes the function return an actual value rather than another version of itself. So that would be our base case. And when thinking about base cases, we want to think about when we want this program to stop. When thinking back into our iterative approach, we have in our for loop, we had our program stop when I became equal to the length of values. So basically what that means is we only want to iterate from 0 to values -1. So that means the last value that we would want to run our program on is values -1. So let's just write stop when I is equal to that length of values -1. Another thing we should think about is recursive call. So what this means is every time we would in our recursive function would always have to call SquareSum recursive or like the function itself again. But the thing is, to avoid infinite recursion, we would want to change something about the parameters so we don't end up calling the exact same thing again. So look at our parameters, values, and index. We should probably think about which one we want to call, or like which one we would want to change. And I think out of the two, I can't think of any reason to change values, but I can think of a reason to change index. Thinking back to our iterative approach with the for loop, every single time we change the value, we incremented I by 1. So we change the value of I, our index. So we can emulate that here by changing the value of index or incrementing it by 1 every single time we call. So for a recursive call, we say increment index by 1. And yeah, so those are our two conditions for base case and recursive call. And after we have those set, we can start coding. So going to our SquareSum recursive, the first thing I would want to do is I would want to square the value at values index, because I know we want to do that regardless of whether it's a base case or we're doing a recursive call. So let's do values index equals values index and we want to square it, so it's a multiplication. And after that, I think it's best to check the base case. So the base case we established is when I is equal to length of values -1. So that's our stop point. And once we reach our base case, we want to return our values at index. And this should be index, my bad. So it's when index is equal to length of values -1 and return values index. And then, so that's what happened in our base case. We have the if statement to simulate our base case condition. And next we have our recursive call. And then when we do a recursive call, we want to, we would want to return the recursive call. So we want to return, we would want to return SquareSum recursive again, but we want to change something about it. And we want to, so we want to do SquareSum recursive, but we also want to use the values of the index we have right now. So I think it's best, because we still need a sum. So I think it's best if we do index values index, and then we add it to SquareSum recursive. So basically it's taking the value that we got this time at our current index, SquareSum recursive, and we'll move to the next line. And we call again on values, but this time we do index +1. What this is doing is we have a squared value of values index, and we call it, and then we're adding it with recursive we're adding it with everything from index, the square value of everything from index +1 onwards to the rest of the array. So basically when you're going through the function, it will run this through until it gets to the end, and then at the end it returns the squared of the last index, and then it will add it to the squared of the last index, the previous index, and then return that, and so on until we reach the end. And yeah, so that's how you would implement both SquareSum and SquareSum recursive. And hopefully that helped you understand iteration or recursion more. Thanks for watching.